Hello everyone, in this video we are going to discuss about provisions related to the permissible deflections of various types of beams. Next is check for deflection. So obviously this is known as serviceability criteria. Okay, so if we see the check for deflection, obviously why we have to prevent the deflection? So based on some conditions like first is aesthetically displeasing. For example, you are sitting in some classroom or some house, so you're staying in some house. So assume that there occur some deflections like this or vibrations. So you are able to stay in it. You are willing to stay in it. Tell me, are you willing to stay in such a building? Obviously, no. Even though it is strong enough to take the loads, whatever coming onto that structure, but still, as it is producing excessive deflections or vibrations, so that is not giving us the psychologically good effects to you. So obviously you are not willing to stay in that. So that is aesthetically displeasing. And that too, if continuous deflections and vibrations take place, what happens? The cracking takes place. If that crack propagates continuously, then failure. So these are the some conditions. So for that we have to check the deflections. It means, again, if you see in strength of materials, I guess we have discussed some 14 to 15 formula standard cases. That is like, for example, simply supported beam with center point load. What is the maximum deflection? Maximum deflection occurs at the center, which is equal to WL3 by 48 EI. For same simply supported beam with UDL, 5 by 384 into W small WL power 4 by EI. Agree or not, sir? Likewise, if you take cantilever at end point load, that is PLQ by 3 EI. So like that, for some 15 to 16 cases, we are having standard deflections. Agree or not? So those are the deflections in the structure or the beam because of the external applied load. So now IS code has given some standard values. It means like how we have discussed the slenderness ratio values. Likewise, here there is a maximum permissible deflections values also. So IS code has given maximum permissible deflection values. So now whatever the deflections that are producing in the structure because of the external applied load should be less than or equal to the permissible deflections. Agree? The permissible deflections given by the code. So now here the code, the permissible deflections as per the code is, so as per IS 800 2007, okay, as per IS 800 2007, the maximum permissible, okay, the maximum permissible deflections. So first, for simply supported beam, so here again there exist two cases for elastic cladding okay, and then for brittle cladding. So now, what is meant by this elastic cladding and brittle cladding? For example, assume that this is a beam. Okay, assume that this is a beam. So if this beam is supporting the elastic materials, okay, if on the top of this we have placed the elastic materials or ductile materials like mild steel or some other material, then what is the deflection? And brittle cladding means, so assume that this is a beam. So on the top of this beam, if we have placed the glass or chalk paste like that, so brittle material. So if we place the brittle materials, what is the deflection? Clear? So if we place the brittle materials, then what happens? We know that brittle materials fail suddenly, or the failure condition or failure of the brittle materials is sudden without any intimation or without any indication. Agree or not? So that obviously deflection in this case should be less in comparison to elastic cladding. Do you agree or not? The reason, the brittle is like a chalk piece. If you take a chalk or a glass, so easily they will fail. So if you produce a small deflections also, they will fail. So that is the reason in comparison to the elastic case, for the brittle cladding, the permissible deflection should be less. So for simply supported beam, for elastic cladding it is span by 240. For a brittle cladding it is span by 300. It means if you see an example, for example, simply support beams UDL. So this is a simply support beam with UDL. So for this case, what is the delta max? 5 by 384 WL power 4 by EA. So now, assume that it is elastic cladding. Okay, so this is the elastic cladding. Now this should be less than span by 240. If it is a brittle cladding, then it is span by 300. This is how to check it. Okay, this is how to check it. So take it out. Okay, so now next let us see for a cantilever. For cantilever. So again, for elastic cladding in cantilever, it is span by 120 and it is 240. So again, if you see an example, take a cantilever beam with point load, okay, W. So what is the end deflection delta max? WLQ by 3EI. So this should be less than, if you assume it as elastic cladding, this should be less than either this or this. That is the meaning. That is how to go for check. Okay, this should be less than this permissible value is given in the code. So these are the external deflections, or you can say the deflection produced because of the external applied load. So the deflection values what are given in the code should be greater than that calculated values. Then only it is good in deflections. Okay, it will not fail in deflections. So that is for cantilever. Take it down. Okay, so next is for Purlin. So next is for Purlin. So I'll explain about this Purlin after this topic. Means after the beams, plate cutter and gantry cutter, we are going to discuss industrial roofs. There I'll explain about the Purlins and I will show all the diagrams and where it is used. But as of now, you remember the provision regarding this. For Purlin is also a beam. Okay. So for Purlin, if it is elastic cladding, it is 150. If it is brittle cladding, it is 180. So these are the values. Okay. So these are the three criteria. So far we have discussed about the design of beam in bending and design of beam in shear and design of beam in deflection. So these three criteria are called as primary criteria.